all to those who are present over here in the webinar on solar thermal desalination technologies, which is going to delivered by Mr. Prasang Rak, who is PhD scholar at the Department of Soil and Water Conservation Engineering, Junagadh Agriculture University. He completed his bachelor degree at Anand Agriculture University in 2017 and his post graduation in Kerala Agriculture University. So, in this era of the renewable energy and water scarcity, this is a very good topic on solar thermal desalination. So, I welcome Mr. Prasan Rag on behalf of Parol Institute of Technology, Parol University. Uh, uh, it is up to you now, Prasan. Please carry on.
Thank you, Partha, for the brief introduction. So, as Partha told brief about me, so I'm directly going to the my presentation. So, am I audible, everyone? Hello?
Yes, yes, you are very much audible.
Yeah, thank you, sir. So, we all know that what is like thermal desalination technologies. I will give a very much brief into this all thermal desalination technologies. So, coming to the introduction, like we all know that there is only 3% of fresh water available in the earth. Like 70%, 80% is salt water in the ocean. So, for irrigation purpose, drinking purpose, for everything we need fresh water. And fresh water is very scarce in the earth. Also, if you like, it is very expensive to convert salt water into like fresh water. And also now, due to global warming, the rainfall is very infrequent. So somewhere there will be more rainfall, somewhere there will be less rainfall. So due to that, the fresh water availability is very scarce. And also due to seawater intrusion in the groundwater is getting salty due to the seawater intrusion. So we need a source of energy through which we can convert salt based this seawater to convert into fresh water. So solar is one of the best source available, renewable source available to us. Like if we use thermal technologies for like coal or any petroleum to convert this seawater into fresh water, it requires more uh, coal and this renew. It is in renewable sources, which can be like less, which is very less in the earth. So solar is very good source of energy for us. So solar desalination can be in the two way. One is direct solar desalination. You can use the sun heat energy to convert this seawater to fresh water, or also we can use some air or any liquid fluid to get the heat from the solar. So we will go into that. What is desalination? So briefly, we can say that if to convert salt water into pure water, we need some amount of energy. So this energy can be get from any renewable or non-renewable sources. So Kalgirov S in 2005 told that 10,000 tons of year 10,000 tons of oil is required per year to convert 1,000 meter cube per day pure water. So you can see how much oil is required to convert this amount of pure water. So worldwide nowadays, this solar technologies, like renewable technologies, are getting more and more popular. So compared to hydroelectric energy, solar, wind, and geothermal energy are more used more 1% more worldwide. So in this way, we can say that solar desalination plants are very much required, and it should be like popular in every country, and it should be planted in nearby sea areas. We can say that solar is a free energy, and also this solar desalination plants doesn't require any moving operation, so it is very low cost. So operating cost is very small, very low. But the main demerit is that it is having very low efficiency. So it can be used for small scale production, and especially in the arid areas, means where the sunlight is more and we are getting more heat. So in these remote arid areas and island, we can use solar thermal distillation technologies, and also conventional energy such as coal or petroleum is very scarce. So in this we can use solar thermal distillation technologies. So coming to the different types, so direct solar desalination. In this, we can say we are using the sun energy directly. So here we can see that solar radiation is coming from in this part. So directly, in the third effect, if it is getting the energy and it is getting evaporated and condenses over this cover, and we can collect the water from here. So this is direct solar distillation technology. And other way, if you can say, we can use the solar energy collected through some flat plate collectors or any other things, we can use hot air. So from that hot air, we'll use prepare electricity, and that electricity we can use in conventional distillation plants such as multi-effect, multi-stage flash, and reverse osmosis. Different types of this is a process in which electricity is required more, and this electricity can be produced by the solar energy. So this is also called as indirect solar distillation technology. So coming to direct solar distillation means what? So this is a picture in which there is a sea water here in the bottom of the uh, solar distillation tank. This is a glass cover. So the radiation which is coming to the bottom of the like this uh, plant, this solar distillation tank, the heat energy will be converting this seawater into water vapor, and compared to the outside temperature, inside temperature will be more. So the water vapor will condense over the glass, and this condensed water can be collected at the bottom of this tank, and this way we can get the solar. In this way we can get fresh water, but you know it is very less effective. So we will get only 2000 meter cube per day if it is in the big area. So it is having low operating temperature and low pressure. So we will get less efficient. So this was a solar still, so a single effect solar still. There was only one side, the glass. So this distilled water is generally portable. So what is potable water? Potable water means that it is a drinking water. I mean, it is free from salts, inorganic and organic components. Also, microbial bacteria also are removed. So this way we'll get this fresh water which can be used for drinking purpose. And also after the salty water is getting water vapor, the sludge will be formed at the bottom of the tank, which can be flushed out through any external water flushing device. So it is said that to produce maximum 9 liter per meter square area per day of water, including heat losses, it requires maximum 250 watt per meter square solar radiation for 24 hours. So it is very much less effective, because we require 250 watt per meter square for 24 hours. And also Garcia Rodriguez studied this single effect solar still, and they stated that 30 to 40 percentage efficiency is giving 30 to 40 percentage efficiency, which is very low. So it is having low thermal efficiency and also low productivity. So it is said that to evaporate 1 kg of water at 30 degrees Celsius, it requires 2.4 into 10 raised to 6 joule of energy. So this much amount of energy to get from sun, we require more efficient techniques of solar desalination. And also Shanmugam et al. In 2020 experimented that if we keep some nanoparticle coating at the bottom of the steel, the evaporation will get increased. So they studied this titanium dioxide nanoparticles coating, and they got that around 57.60 percentage of efficiency was there in summer, and 36.69 percentage of efficiency was there in the winter. So they got the increase of efficiency through the nanoparticles coating, but which is either way also an expensive thing. So now coming to indirect solar desalination technologies. So in this, we are not using direct solar heat, but we are storing the heat energy and we are using it to produce electricity or any other heat source medium for the solar desalination. So solar pond. So it is generally constructed a shallow pond in which they are having three layers. The bottom layer is having more saturation of salt. So salt concentration will be more in this area, less in this area, and this will be relatively fresh water zone. So whenever the solar radiation is coming here, it will get hit inside the more concentrated water, and this heat cannot be get lost due to the more concentration of salt. So the water heat will be trapped here in the bottom layer, and that through some heat exchanger or any tube water we can use this hot water at the bottom for solar desalination or any electricity. We can use that heat to produce electricity. So generally lower layer is getting 70 to 85% degree Celsius during the daytime. In summer and winter that can be different according to the temperature. This solar pond is used for getting heat from the bottom of the layer, but it is having only 10 to 15 percentage efficiency if we are using small ponds. If we are using large ponds, the efficiency will increase according to the size of pond. So this is a more convenient source. There are no moving parts, so we don't need any mechanical thing. It is a simple thing. Also, it is inexpensive. So yeah. We can also optimize the solar salinity gradient solar pond. So solar pond also named as salinity gradient solar pond. So there is a difference between salinity between two layers. So it is called salinity gradient solar pond. We can use some optimization technique to increase the evaporation. So they have used an NaCl and Na2SO4 mixture to optimize the solar pond efficiency. The Asari et al. Studied this in 2020, and they found that control amount of Na2SO4 improves the thermal and salinity stability. So different amount of Na2SO4 and NaCl were studied, and they found that some control amount of Na2SO4 will improve the thermal stability and also improve the storage capacity of heat at the bottom layer. So a high percentage of Na2SO4 requires less time to stabilize and also reduces the density gradation. So it causes the rapid destruction of upper layer. So it was found that 0.75 percentage of Na2SO4 was perfect and optimum for maximum extraction of heat from the solar pond. And they to prevent algae, they spreaded HCl spray and a high percentage of Na2SO4, so the algae won't be covering the surface area. So in this way, Sari et al. Studied this solar pond, and he gave the how we can optimize the solar pond energy and how we can use it. Now coming to the another indirect solar distillation technology, flat plate collector. So what is this? So in this, this is a box in which there are absorber pipes which are having selective coatings, and these pipes we are transferring some heat transfer fluid. This heat transfer fluid can be either water or air, anything we can use. And this we are covering these pipes into the we are covering these pipes through selective coatings, which reduces the heat loss and also increases the radiation absorption. So we can use like black color pipes, so which will increase the radiation absorption. So it was not much efficient. So the flat plate collectors were not found any useful for desalination technologies because using this hot water or hot air, it was not getting much efficiency compared to the direct solar desalination technology. So what they did this, they used FEC for additional energy source. So if we are using some major energy source like electricity or something, if we are getting less, then we can use this FPC for additional energy source to complete the whole solar desalination plant. So in Mexico, this desalination facility derives energy from flat plate collectors and parabolic troughs. Parabolic troughs are also like type of parabolic glass reflectors which concentrates the energy at the center of the uh, any material which can get heated, and we can use that heat source from that. So in this way, FPC is used. Then coming to evacuated tube collector, so we have all shown that on the top of our route we are having solar water heater. So in that there are different types of tubes, and in these tubes they are having two glasses. So in between two glasses they are having vacuum. So why we are having that vacuum to decrease the losses due to infrared radiation. So in same way we are using this evacuated tubes, which is having two tubes, and in between two tubes there is a vacuum to reduce heat loss, and also we are having the inside tube will be having selective coating to increase the absorption thing. This tube is also called as Divar tubes. So these tubes, due to vacuum and selective coating materials, it is more sophisticated and also it is more expensive. But due to less losses of due to infrared radiation, we are getting more temperature. So around 200 degrees Celsius temperature we can attain through the evacuated tube collector, and it is having very high efficiency. And compared to the cost, it is around $200 per meter square to $550 per meter square. So this it is a high temperature distillation plants also we can say, which can be used to for solar desalination, and also the cost is optimum, which can be used at the plants which is on a medium scale plants. Now coming to the high scale plants which are having the more area, which we can use multi-stage flash process. Alico O in 2017 studied the whole process. In this, there are several chambers in the it is in the more area we can use this multi-stage flash process. So there will be several chambers, and pre-treated saline water will be used. From the after before, so here you can see the process. So here there will be different nth stage, so different stages of flash process will be used. So high temp the first process, high temperature and high pressure, will treat the pre-treated saline water. So due to the high temperature and high pressure, it will the boiling point of water will get reduced, and it will directly get into the first stage. So first stage, water will be sprayed. The brine, the hot due to this hot water vapor will get above and will condense from this pipe. So it will be collected here, and again it will go to the second one. So in this way, different stages, the pre-treated saline water will be passed, and at the end of the end, so we can calculate the number of stages according to our volume of flow. And at the end stage, we will get the fresh water as a product, and also sludge or brine we can collect it from the bottom. So boiling water in the fresh chamber, the pressure is suddenly reduced. So due to that, the water will directly get into water vapor, and it will get condensed above, and again it will go to the second chamber. So different type of different chambers will be continuously going. So in this way, we are using this multi-stage flash process. So coming to the My screen, if you are getting my screen.
Yes.
Yeah. So when was I removed, sir? Like when was I?
Next slide. Next slide.
This was completed.
Yes.
Yeah. This one.
This. Yes. Go on. Go on.
Okay. So this as we studied multi-stage flash process,
Please go
different
on. Go on.
scientists.
Next. Next.
Okay, sir. Next slide.
Could you please minimize the presentation?
Yeah. Yes, sir.
This slide. Yes. No. No. Next. Next.
Oh, yeah.
14th
This
number.
one.
14th.
14. Yeah. Okay, sir.
Yes.
So uh, same this multi-effect distillation is working at same principle on multi-stage flash evaporator we studied in the previous slide. So in this, what we are having different chambers. In this each chamber we are creating vacuum conditions. So what will happen due to vacuum conditions, the heat evaporation temperature will get reduced and the evaporation will be very fast. So as you can see in photo here, in every chamber we are using vacuum, and the seawater will be fed from the top. The steam will be come from this boiler, and the water vapor will the water vapor of first chamber will be used as a heat source for the second chamber. So the efficiency of the uh, plant will also increase. Will use the pump to transfer all the brine water from each into the each chamber. So through this distillation process we are getting we are using the heat source of previous chamber. So this require very less amount of heat energy, and also it is very efficient. And also the fresh water will be connected from each chamber. So it is it is working on the same principle as the previous one, but here we are using vacuum conditions, and it is more efficient than uh, multiple flash chambers. So if we are having if we need more efficient, we will increase the multiple number of chamber. But what happens if we use number of multiple chambers? We need to create vacuum in each chamber. It will require high uh, like operating cost. So we have to consider some optimum number of chambers for optimum flow of water to be uh, converted into fresh water. So more number of chamber, higher number of performance ratio of multi-effect desalination. So Fiorenza in 2003 estimated production cost that to produce 500 meter cube per day, it requires $3.2 per meter cube. And if we require more water, then the cost is getting reduced. So see, from 500 to 5,000, the cost is reduced from 3.2 to $2. So higher the chamber, it will reduce the number of uh, the cost of per meter cube of water to produce the dollar like what is uh, like dollar or rupees to produce per meter cube of water, it will get reduced. So we can also modify the plants. So we study direct and indirect solar distillation plants. In this, we can modify each and every plant to increase the efficiency. So to to augment the operative performance, you can use several techniques. So here, the first one we studied the single effect solar cell. Here we are seeing double effect solar cell. So two side glass we are keeping, and at the both side we are collecting the fresh water. And in this way we can increase the basin still performance. So again, what we can do is in single effect still, if we are keeping two glass and in between two glass we are continuously flowing the cooling water, the efficiency will get increased. Why? Because there is a higher temperature difference between basin and the cover. So evaporation rate will directly get increase. So uh, any cooling water or saline water we can use to like flow from that gap. So it will increase maximize the temperature difference between water inside and the water flowing from the top. So condenser will also increase and we can get uh, more fresh water. But this cooling, so the cost is also high in this. So we have to make this arrangement, and also we have to continuously plump the fresh water. So it will also increase the cost, but we'll get fresh water and efficiency will also increase. So here the Manjunath in 2020 studied and stated that distillation output is increased 3.32 times compared to the non-modified version. And also the this single still efficiency is increased 7%. So we can say that it increases the output capacity and also efficiency of the steel. Then instead of the water flowing, you can use some pump or any additional condenser to condense the water at the top of the shaded area. So Fath at 2002 founded that by adding passive condenser in the shaded region of this is glass, it is called a shaded region. So if we are using some additional condenser by single slope steel, the efficiency will increase 45%. But also we are using some fan on electricity. Again, the same thing, the operating cost will be high. So also, another modification is like in the seawater, if we black dye is mixed with that, black dye act as a absorption thing. So more heat will be absorbed from the sun. So the temperature, the more water will be evaporated. So injecting black dye in the seawater increases the distillation yield by 11 to 16%. So as the efficiency or the estimation yield increases, the cost will also increase because the black dye, like the cost of black dye will also increase. The how much percentage of black dye to the absorbed in the water, how much percentage we have to study everything. So in this way, everything we can use. Then also weak steel. So what is weak? Like weak is the what we call in Gujarati we call kothra. So that if we just if we spread over here, the evaporation of the water will increase. So weak steel we are using as weak material to spread over the tilted this plate, and absorption will also heat absorption will also increase. We have to make some optimum angle for the better angle so that we can get more absorption of heat. And each and every time from here the floating heat will allow the water, only small amount of water to come over this thing. So less water at a time, so more quickly it will get heated and more uh, with high temperature, so more evaporation will be there. So Tanaka in 1981 stated that superiority of tilted weak productivity increased from 20 to 50%. So we can use any weak material to increase the productivity. So compared to the basin steel or single effect basin, previous one non-modified, the efficiency will be far better in simple wick steel. If we are using some complex wick steel, it will get more efficiency, but the cost will also high. But simple wick steel, it is lightweight, low cost, and it is having a significant output. So the hybrid structure of heat localization materials increase the heat evaporation. So what is this HSHLM? So it is different type of material. See here we are seeing carbon like graphite flex, carbon foam, and combination of both. So this one was graphite flex. This one is carbon foam. So these two materials we can use to increase the as a weak to increase the evaporating or high absorption, and also hydrophilic capillary force. Due to this, the material ability to capillary the water, it will the temperature of uh, evaporating temperature will decrease, and also less amount of water we are keeping over the wick, so the efficiency will directly increase. So here see the productivity of graphite exploited graphite flex used as wick increases 34% productivity. By using carbon foam, it is 28.6, and by using combination of both graphite flex and carbon foam, the productivity increased 51.8 percentage. And also the effect of efficiency of solar steel in combination of both increased 37.6 percentage. So in this way, different type of wicks we can use to increase the productivity of solar steel. Now another aspect is greenhouse. We are now greenhouse is getting more popular. So what if we use greenhouse and solar steel both as a combination? So here we can see the photo. At the top, we are having the single steel evaporator, and this is the greenhouse. So water is pumped at the top of the solar steel. The water will get evaporated, and the fresh water we are collecting here. And this fresh water we can use to irrigate the plants in the greenhouse. So what is benefit of it? So uh, the inside temperature will get minimized due to the solar steel at the top. The inside temperature will be optimum, so transpiration will get reduced. And also it is used in small scale systems only, because at the top we can't use a heavy system. So 25 meter cube per day or less only we can use, and also in the remote areas. So the wavelength transmitted in the greenhouse is photosynthesis wavelength from 380 to 710 nanometer. So the temperature of water at the top won't be much, and the efficiency won't be as compared to the other types. But the temperature inside the greenhouse will be lowered, and the climate inside the crop will be better. So we won't require any ventilation thing requirements, and also water consumption of the plant will reduce because the transpiration is reduced. So in this way, this solar steel greenhouse combination can be very useful. The heat inside the greenhouse can be used at the night time also to evaporate the water in the top. So Davis and Patton in 2005 stated that the amount of fresh water produced exceeds the evaporation requirement of the crop. So in the daytime, the transpirated water will be less, and also evaporation will be less due to the solar steel at the top. So what they told, that amount of fresh water produced from the solar steel, it is more than the evapotranspiration of the plant inside the greenhouse. So if we are using this fresh water as irrigation, then also we are having some amount of water left with us for the other purpose. So this is a very modern concept, is solar steel greenhouse combination. Multiple effect basin. So we studied that solar steel of single effect. So what we can do is we can have 3 or 5 layers of single effect solar steel to evaporate the different amount of water. So 2 or more compartments we can get over the each steel. So multiple effect solar distillation systems are more productive than single system due to reduced latent heat. So to transfer from liquid water to water vapor, less energy is required. So multiple effect solar basin steel is more efficient than more productive than single effect steel. And also the increased efficiency surpluses and increased capital and operating costs. So we require more heat to increase the because there are different types, different compartments. So each and every compartment required the heat to evaporate. So in this complexities are also more, cost is also more, but efficiency is around 35 or more we can get compared to the single effects system. Scavarzer in 2001 experimented that with desalination with six stages. So here we saw the photo of 3 stages. Same way, for 6 stages he studied for desalination, and he found that production rate reached 25 liter per meter square per day for a value of around 4.8 kilowatt hour per meter square per day of solar radiation. So we can get a much amount of water from multiple effect basin still compared to single effect basin. So in this way, we can modify it. So there is a small case study. At the first, we have seen that use of nanoparticle at the bottom to increase absorption. So that case study, a small case study, I have taken. Um the case study was at the Research Center of Physics in the Andhra Pradesh, India, during January 2018 to February 2019, with global radiation around 1100 watt per meter square. So what they did, they used uh, titanium dioxide nanoparticles and mixed with CrO2 and O3 coating for the basin area to achieve more absorptivity. And titanium isoperoxide was used for titanium source. So this mixture was used as the coating for basin area. So at the bottom of the area, they used this nanoparticles material to increase the absorptivity of this sun. So they got result for so without coating and with coating in the summer and winter season, and solar radiation and the time for the day. So the blue one, so we can see in the uh, area with liquid coating in the winter season, and summer season it got high, and without coating is winter and summer it got low. This one temperature attained, the temperature attained was in the summer with coating, and in winter with coating got high. In the same way, efficiency of the plant, same way it was increased in with coating and in summer and winter season. So here we can see that the coating material or modification in the basin still increases the efficiency of the plant and also the production rate. So here we can see that production rate was 6.1 kg per meter square per hour in the daytime in the summer with coating. In comparatively, it got reduced in the coming one, and also at the night time also due to the heat stored. The night time also they got around 4 like 1.792 kg per meter square per hour output. So this is a very much at the night time in the summer. So this type of coating materials or anything we can use to increase the absorptivity at the bottom. So the conclusion of the case study was that advantage of nano layer coated is the ability to raise the temperature of basin by 60.1 and 70 degree in the winter and summer season respectively. So here we can see around 70 degrees Celsius in the summer and 60 degrees Celsius in the winter was achieved due to this nano layer coated uh, bottom. And also daily yield was in with 6.1 kg per meter square per hour per day and 4.1 kg meter square per hour per day in the summer and winter respectively. Summer we got 6 kg, and in winter we got 4.1 kg. So this is very much high efficient system. We are using nanoparticles, but again the cost will also high. But different studies are going on. So with less operating cost, we are getting more productivity. And also the efficiency of system in summer with coating was 57.16% compared to the non-coating 27.72%. So see how much efficiency it got increased. And also in winter season with coating it was 36.69% and compared to non-coated 24.03. So here we can see the differences. In summer, due to high heat, the efficiency increased 30%, and here we got only around 10 percentage or 12 percentage increase in winter. So in this, if we use these modifications in the different conventional plant, we can increase the productivity. And the main aspect of these plants are to get more and more output and with a less amount of operating and maintenance cost. So the solar desalination is a very good type of technique nowadays used with the use of solar energy to get the fresh water which we can use in irrigation or drinking purposes. But nowadays it is under development and research consideration. So in the future we will get some good desalination technologies at the like sea the seashore or any ocean. We can use this type of desalination technologies which can be very beneficial in our future. So thank you, sir. This was all about solar desalination technologies. And any questions? If you have any questions, hello, sir. Hello.
If you guys have any question, then you can write in the chat box of the Facebook, so I can convey it to Prasanth. Okay, thank you, Prasant, for delivering such a good webinar on this topic. Thank you very much.
Thank you, sir. Thank you, sir.
Okay, you can leave, Prasant.
Yeah.
Thank you.
Thank you, sir. Yeah. Thank you, sir.